In the next 5 minutes, you'll learn what prompt engineering actually means, why two prompts that look similar can produce wildly different results, and the 4 techniques that cover almost every situation you'll run into. Prompt engineering is the practice of designing the input you send to a large language model so it reliably produces the output you actually want. It's not just asking, it's structuring your request, providing examples, and adding constraints. The difference between an okay prompt and a great one can be the difference between a useful answer and total nonsense. Here's why phrasing matters. The vague prompt on the left gets a generic, unstructured response. The precise prompt on the right specifies the format, gives an example, and constrains the output, and gets back exactly what the caller needed. Same task, vastly different results. Here's what actually happens when you call an LLM. Your developer code builds a prompt by combining a system message, the user's input, and optional examples or retrieved context. That assembled text becomes the LLM's input. The model processes it token by token and returns a completion. Every part of this pipeline is where prompt engineering happens. The assembly step is what you're tuning. Here's what a well-structured prompt looks like in code. The system message tells the model who it is and how to respond. The user message contains the actual task. We give one worked example, so the model knows the exact output shape we want, and we explicitly demand JSON. Every line is doing real work. Change any of them, and the output changes. 4 techniques cover almost everything. Zero shot is just asking with clear instructions. Few shot means including a handful of worked examples right inside the prompt. Chain of thought asks the model to think step by step before producing its final answer, which dramatically improves performance on reasoning tasks. And structured output forces the model into a parsable format like JSON. Here's the same problem with and without chain of thought. By adding the phrase think step by step to the system message, we get a much higher accuracy on math and reasoning problems, because the model literally allocates more compute to the intermediate steps before committing to a final answer. Prompt engineering is the right starting tool, but it's not always the right final tool. Fine-tuning bakes new behavior directly into the model weights, which is expensive but powerful for narrow tasks. Retrieval Augmented Generation, or RAG-E, dynamically injects relevant context from your data into the prompt. As a rule, start with prompting. Reach for the others only when prompting hits a real wall. 5 rules that hold up across almost every prompt you'll write. Be specific about what you want. Task, format, length, tone. Show concrete examples instead of describing requirements abstractly. Ask for reasoning explicitly when the task involves multi-step thinking. Demand structured output whenever something downstream has to parse the result. And iterate one variable at a time so you can tell what actually moved the needle. That's prompt engineering, designing the input so the output is reliable, structured, and useful. Start with clear instructions, add a few shot example or two, ask for step-by-step reasoning when it matters, and force structured output for anything you'll parse downstream. Master those 4 moves, and you'll handle 90% of what an LLM can do for you.